Okay, it's Friday, so I'll give you a little video today. I'll give you one to work on your own on Monday. You got to simplify the radicals. So again, we're going to put a radical 4. And we're going to see how much stuff I can get out and how much stuff would remain in. So we have the radical 4, 1,250. Then a radical 4, x to the 9th. Radical 4, y to the 3rd. Okay. So I need to be on my 4 list, and I need to divide into that and rewrite it, because that's not on the list. I never see a 1,250. I'd start here. I would start dividing at 625, so it'd be 625 and 2, because that's what I get. So we switch that then to 5. So a 5 is outside, and now a 2 is inside. Okay, x to the power of 9 would be 9 x's. I know that's a lot to write, but that's okay. And I group them into 4. And every time I group a 4, then x comes up. Now, these x's that came up go outside of the radical. Since there are 2 of them, we put x to the 2nd power. There's still an x inside, so that will leave there, that one there. Y to the 3rd is y times y times y. Well, I can't do 4, okay? So I have y to the 3rd inside. We didn't get any ones we could circle up there, so it's y to the 3rd still inside. Okay, number 2. Remember, that's a 2 if we don't have it. So I got the square root of 25, the square root of x to the 5th, and the square root of y to the 3rd. So square root 25, that's 5, okay? Okay, so I got a 5, and when that shows up on here, that goes outside. Okay, remember that. So 5 outside. Nothing inside yet. X to the 5th, x times x times x times x times x. So 2 at a time. X comes up. X comes up. So how many x's do we get to come up? We got 2. So x second outside, and then I had an x left in the end. Okay, y to the 3rd. So y comes up. And there's a y we have to leave in. So if there's only one factor of y of a circled y, I just put y out there, and I'll just put y inside. Okay, number 3, you want to be doing the same thing, but first you want to make it into one single radical. And you do that by multiplying 5 by 10, which is 20 or 50. And then on the y's, when you multiply powers, you add their exponents. 3 plus 5 is 8. Now I do the same thing I'm doing up here. Okay. We have the square root of 50 and the square root of y to the power of 8. Okay, so let's take a look here. I divide into the 50. So 50 divided by 49, divided by 36, no. Ooh, 2, so I got 25 and 2. So the square root of 25 is 5, okay? So 5's out, 2's in. Y to the 8th. Two at a time, then a y comes up, another y comes up, another y comes up, another y comes up, and there's none left. So I have y to the 4th outside. There are no y's inside. Okay, number 4, another multiplication. So remember, my job in multiplication is just rewrite it so it's just one single. 5 times 15 is 75. X, 2 plus 3 is 5. Now what do we do with the 3 and the 2? We need to times those, okay? So I'm doing the same thing I did here. I make a radical 2. I just got to shove the 6 out. Okay, it's still there. I just kick it out. Then I do the same thing I'm doing here. Radical 275, radical 2x to the 5th. So 75, not here, so I need to rewrite it into 2 radicals. So 75 divided by 64, nope. 75 divided by 49, nope. So divided by 36, nope. Yup. So square root of 25 is 5. Okay. So 5 comes out, and we go 6 times 5, and then the 3 goes in. It's times 5, not plus. Okay. So 5 factors of x, 2 at a time, x, and then that one stays. So we got x to the second outside and x inside. Now you do want to times the 6 by 5, and that would be 30. Okay, and that's your answer. Yeah, just cross it out, put 30. Okay, next one, adding. Adding's a different ball game. You look under the radicals and they're different. So what you have to do to be able to perform the adding operation is make your table. And we've got to simplify these so that they become the same under the radical. That's 8, my bad. Okay, so 45 isn't here, so we're going to write it in 2 radicals. And remember, there's a factor of 2 there. So 45 divided by 36, decimal, divided by 25, decimal, 16, decimal, 9, there you go. So we have 9 and 5, and then the radical 9 turns into 3. So now what do we have? We have 2 times 3 times radical 5. That'd be 6 radical 5. So I cross that out, and I have 6 radical 5. Remember, these are 2's. When I don't see them here, I'm looking at this list. And it's likewise with 20. I don't see 20 here, so I divide into it, write it in 2, and remember, you have a factor of 8 there. So 20 divided by 16, nope. 20 divided by 9, nope. 20 divided by 4, yep, 4 and 5. So the square root of 4 is 2. So you have 8 times 2 times radical 5, and that would be 16 radical 5 plus 16 radical 5. Now I have radical 5's in both of these, and that allows me to now add the outside. 6 plus 16 would be 22. Okay, this is the FOIL method here. Okay, so I go 6 to 3, neither one have a square root attached, so it's 6 times 3. 6 to 4, 6 doesn't have a square root attached, 4 does though. 4 has a square root of 3 attached. We're done with the 6. 2 to 3, 2 has a square root of 3 attached, but the 3 does not. 2 to 4, 2 has a square root of 3 attached, 4 right there. So 6 times 3 is 18. 6 times 4 is 24, and I just put the radical 3 behind it. 2 times 3 is 6, and I put radical 3 behind it. Now I'm okay with the radical 3's because they don't show up here, okay, so I leave them. 2 times 4 is 8, and we need to take 3 times 3, which is 9. But the problem is radical 9's on here. That's 3. So we need to rewrite that as 8 times 3. That equals 24. So here are the 4 answers I got. So we need to add the like terms. 18 plus 24. That's going to be 42. Then I put a radical 3. 24 plus 6 is 30. And that's it. You can't add these because 30 has radical 3, 42 does not. Okay, now solving equations. So first, here's my radical. You got to get rid of the plus 2. I'd subtract 2. Takes us to 2. And I now have the radical of x plus 5. Now to get inside there, to be able to minus 5, we have to get rid of the radical first. So the inverse of a radical is a second power. Always. So we get x plus 5 now by itself, and 2 to the second is 4. Then I subtract 5, and I get negative 1. Okay, my next problem, so we have a rational exponent. Rational exponent means it's a fraction, okay? And that involves using this sheet later. First, before we worry about that, we have to divide by 4. So x to the power of 2/3 equals 4. Now to cancel out a rational exponent, we parenthesize both sides and flip the exponent. So what does that even mean? 4 to the 3 over 2 power. Well, the 2 means that's a root. So I want to look at my root 2 list and see if 4 is on here. It's 2. So I have 2, but don't forget you have to now raise 2 to the 3rd power. And 2 times 2 times 2 is 8. Okay, 3 2's. Okay, number 9, here's my radical. You have a times 5 and a minus 6, so you plus 6, that takes you to 40. Then we divide by 5. Now I'm at 8. And now I just have the radical that I need to get rid of. I can't minus the 3 till the radical's gone. So I take it, and now it's gone. We have x plus 3. And 8 to the second means 8 times 8, which is 64. Oh, don't circle that. We got a minus 3 still. I'm sorry. That's 61. 61's the answer. That's not the answer. Okay, number 10, we just have the exponent. So if it's a rational exponent, we just reciprocate it, meaning flip it. Oh, 4 over 3. My bad. 4 over 3. 4 over 3. So remember what that means. This means the cubed root of 125, which is 5 to the 4th power. So I go on a calculator and I find out what 5 times 5 times 5 times 5 is, and that's 625. There we have it. Okay, number 11, graph the function. So remember your parent function. Parent function is like the base of just with the square root if the 5 wasn't there. So remember, you can only put positives in a square root. That's why you start at 0, and then you pick numbers that actually come out as perfect squares. So 1, 4, 9, in that order. And the square root of 9 is 3. The square root of 4 is 2, 1, 0. Now, where's that minus 5 at? It's inside the radical. So inside the radical, we have to do the opposite, okay? And we have to do it to the x. So I have to add 5 to all these x's. So that's 14, 9, 6, and 5, okay? I don't do anything to y because I really don't have anything on the outside. So 5, 0. 1, 2, 3, 4, 5. And circle that point because that's your first point you could possibly have. 1, 6. Or no, 6, 1. I'm sorry, I screwed that up. 6, 1. That would be right here. Okay. 9, 2. And then you go off the graph, so just go like that. Okay, if you run off the graph, don't worry about that point. So the parent function is translated 5 units to the right. Okay, number 12, parent function. Three, 2, 1, 0. Now it's outside. Okay, it's outside. What's outside, we don't do the opposite, so it's not opposite. And we do it to the y. Okay. So we're going to do it to the y now. Okay, so plus 4 is what you do to all your y's. So 7, 6, 5, and 4. So 0, 4. 1, 5. 4, 6. 2, 3, 4. 1, 2, 3, 4, 5, 6. 9, 7. Okay, so this time the graph has shifted up 4 units from the parent function. Okay, that's all I have to say on that. Keep those as notes so you can use them Monday when I give you your packet. Okay.